Hi everyone, this is Bharti here. So in my previous video, I have explained about the linear regression. So in this video, let's learn about the logistic regression. So what is logistic regression? As we know, it is one of the algorithm in supervised machine learning. It is best for the binary classification problems. Binary classification problem in the sense wherein the output, that is the target, will be having yes or no, mm, success or failure, male or female. So that is called as a binary classification problems. And it uses the sigmoid function. The ultimate goal is to find the best fitting model for independent and dependent variable relationship. So we can conclude saying that logistic regression is a classification algorithm. It is used to predict a binary outcome based on the set of independent variables. So let's move to an example. So here we have a cancer detection example. So based upon this x-axis value, we have to find out whether the person is having a cancer or not. And as I said, the output, that is the output, that is, it will be on the y-axis, and it is having the value from 0 to 1. So basically, here we can see that our x-axis has both negative and the positive values. So when we try to find out if our data falls under this particular below 0.5, then the person is not having the cancer. If our data is falling under from 0.5 to 1, there is a chances or the person might be having a cancer. So basically 0 says that there is no possibility of occurrence, but this 1 represents there is a possibility of the occurrence. And here it is 0.5. This is called as unclassifiable, and we have very rare and very less incident wherein our data points falls exactly under this 0.5. As I said, but this is very rare in the situations. So here this x represents the x values, and it is having all the negatives and the positive values, and y has the data points starting from 0 to 1, and this is called as a sigmoid function. And here we can see this 0.5, it is separating the data equally. So sigmoid function, so the sigmoid function is trying to convert this independent variable into expression of probability with respect to dependent variable. As we know, as we had taken this example, like we are calculating what is the probability of having the function, what is the probability of a person having a cancer or not. So as I said, if our data falls in the range of from 0 to 0.5, there is no chance, the person is not having a cancer. And if the person is falling, if the data sets are data points are falling from 0 to 1, there is the person is a cancer. So we have an equation for linear regression, that is y hat is equal to 1 divided by 1 plus e minus z. So in order to calculate this sigmoid, this is called as a sigmoid. In order to calculate this sigmoid function, also we are having an equation. So for our convenience, let's try to convert this y hat is equal to 1 divided by 1 plus e minus z as a z is equal to w dot x plus p, wherein z is our output, that is a y hat, that is the output what we are predicting. So y hat represents the probability that y is equal to 1. So x represents the input features, b represents the bias, and w represents the weights. That is, number of weight is equal to the number of input features in the data set. So as I said, for sigmoid function, we will be using this equation, that is y hat is equal to sigma by 2. So even logistic functions have some of the advantages and disadvantages. So moving on to the advantages, as we know, it is very easy to implement and efficient to train. And it performs well on data with linear relationship. If we have low dimensional, that is very less features of the data, the overfitting issue will be less. Logistic regression not only gives a measure of how relevant a predictor coefficient size is, but also it is a direction of association of positive and negative. So moving on to the disadvantages, high dimensional data set causes overfitting. That is, if the features of the data set is very high, it causes the overfitting issue. And it is difficult to capture the complex relationship in the data sets. If the number of features is more in the data set and it is difficult to capture what is the relationship between the feature and the target variable, because we have to calculate each and every relationships. It will be very difficult to be capturing this each and every relationships, and it is very sensitive to the outliers. And logistic regression can only be used to predict discrete function. It can be used to predict the discrete function. Therefore, dependent variable of logistic is restricted to have a discrete number of set. This restriction itself is a problematic, as it is probability to prediction of a continuous data. So that's it for today. Let's all catch up in our next session. So please subscribe to my channel for few more interesting topics. Thank you all.